This is the 5th tutorial for Wesbeam's eHouse Beam software. Now that we have an understanding of how to set up our software preferences and timber lists, design basic structural members, and modify the support conditions, we're going to have a look into the design of floor bearers using specific loads. This function is aimed at experienced engineers, specifiers, and estimators who have a firm understanding of building load paths. Under the Floor Bearer tab, select 2-span bearer calculator. This can also be done for single span and triple span bearers. You will notice that instead of an illustration of the type of beam you are designing on the right hand side, the illustration shows a cross section of the beam. Firstly, let's input our spans and material types. Now that we've input our spans and cantilevers, the illustration on the right hand side shows these changes. In the Wesbeam span charts available at wesbeam.com and in the basic floor bearer options on the eHouse Beam software, the loads are applied to the length of the beam in a constant and consistent manner in accordance with the loading criteria specified in AS 1720.3. For the bearer calculator function of eHouse, the loads can be manually entered at any point along the beam and for any length. Click on the loading to begin adding design loads to the beam. Click on the Add button to see the types of loads that can be applied. For this example, we're going to add a roof load area to the end of the cantilever. This will be typical of a support post being constructed on the end of the beam. Note that the start dimension is measuring from the left-hand side of the beam shown in the diagram. The load applied will then be determined based on the roof area and the roof type that we've previously selected. As you can see, the diagram now shows the point load on the left-hand side of the cantilever. Let's go ahead and add another load to the bearer. This time, we're going to take a load from the floor joists themselves, which will be supported by the bearer. Select floor load width as the load type. In this case, let's say there's a void in the floor within 3 meters of the right-hand side of the beam, which for an 8.8 metre beam would be from 5.8 metres onwards. Now that we've chosen our floor load of 3 metres in width, this will be added to our calculation. You can continue adding different loads to your bearer depending on the configuration of walls and so forth in your architectural plans. I've already preset my timber list for floor bearers, which was discussed back in tutorial 2, so let's go ahead and click calculate. The beam designs on the right hand side show some options for our customised bearer design. Note that the 2 and the 3 in front of the beam sizes denotes a double and triple lamination. By simply changing our criteria under the product filters, we can quickly look at different available options. In this case, let's say we don't want to use any more than a double laminated beam option. Change the max lambs to 2 and you'll see the design options change on the right hand side. Once you've added this beam design to your job, you can come back at any stage to change the spans or add more loads using the edit function as shown in previous tutorials.